Yeah, so hi everyone. My name is Sagar Kakkala, and like today, here we are in a session for DevOps in detail, like where we will be discussing about Kubernetes. We'll be going on a complete overview, but like not in depth. Like while we are discussing about like Kubernetes interview questions, like in the next sessions, we'll be discussing about like how to install AWS EKS, like master node, like Kubernetes architecture, and a lot other stuff. But this session is just a basic overview of like how Kubernetes works. And like since this session would be uploaded in YouTube, I'll share screen to show like how things work in Sargakala's world. All you have to do is remember my name and you have to search in Google Sargakala. One second. Yeah, you'll have my website, LinkedIn, and YouTube. And in YouTube, like every here is Udemy as well. Fine. And then YouTube, like everything is separated by playlist. And here, like this playlist would be uploaded in DevOps in detail with Saragakala. And like before watching this session, like I would recommend to go through the previous two sessions about like Docker and Docker interview questions as well. Because like Kubernetes actually like came after Docker. So that's why like I would recommend going through this. And one second, yes. And here in like website, everything is separated by contents of blog. So you'll have my like DevOps projects and like finance with Sarakala, like the previous projects, AI ops, ML ops, and this like which was stopped in between. And here I'll like make a new session like for day 3 of Kubernetes overview. So like the way it's planned is like we'll have any tool first the overview and then it's interview questions. Yes, one second. Hussein, can you mute yourself? Yes. So here, like since this is just an overview, like before, like when we are having like DevOps to GitOps project, since I had already discussed about the Kubernetes there, like we'll just go there itself. Like I'm using the same blog there to explain things, and like there we had used something called as micro K8s, like which is let's say an alternative and like a cost effective version for Kubernetes. Like since this is actually a mini project that I did there, so that's where I went with like micro K8s. But like for next session, I'd be like taking on like how to install AWS EKS and like how master node like and like worker node works, and even like how Kubernetes upgrade is even done in AWS EKS. And as of now, in the last sessions we has discussed during Docker that like will push the Docker image. So here is where like once the Docker image is pushed in your Docker hub, let's say you could call the same image there. Maybe this is the install of micro K8s. Okay. Yes. So I'll just like go with this same blog itself. So here, like in Kubernetes, everything works with like namespaces as well. Or namespace is nothing but let's say you could think of your own house, a kind of thing. Let's say like this is a house in which like you could have your like everything, let's say like your pods, deployments, ingress, like everything inside one house, and you could name this house. Like that's like where we call it as a namespace. It's just like a kind of uh, a resource, like different resource. Like if we delete this namespace, like entire like whatever is there inside namespace can get deleted. So namespace is nothing but an individual house, you could say, like for example, and you could group everything inside that namespace. So that's where, like in Kubernetes, like we'll discuss about this commands, like the architecture as well later. As of now, we'll just have understanding of basic concept, and like here we will create a namespace first in everything, and like these are called manifest files. Just like Docker has like Docker files, in Kubernetes, we call these files as manifest files. And here, like everything depends on API versions. Like this is app slash v1. In API version, like wherever you want to go inside API version, like it has the kind is like inside API version, like what you're accessing. So this would be the first, maybe let's say one second. Yes, here the API version is like V1, like inside V1 it's service. Same way, like each API version you had to choose, and based on that, like it goes. Here, like for Ingress, the API version is networking.k8s.io slash V1. So, like inside the API version, you had to choose like which kind you're accessing. So that's how a manifest files works. Like these two, like these four were the main important files, let's say. These two to navigate, like where you want to exactly like want your Kubernetes to navigate with, which we'll actually discuss in detail. I'm just going on overview here. And this is like label sessions. You'll go for name and like namespace. Namespace is nothing but the one which I said, like a house thing you'll create. And like once Docker image is created, like if you remember in Docker session, we had deployed Docker image in a Docker container. Here, like we would be deploying the same like Docker image inside a container, but like these would be run inside something called as pods. So we would call Kubernetes here the deployment as pods. So let's say, and like one more thing, like why Docker has shifted to Kubernetes is because let's say if you want to run one application in Docker, let's say if someone like if you had turned up an application and like let's say like this is Docker container, and if your load is getting high, let's say the load is getting high, and like what you had to do is like you had to turn up another Docker container manually, and you had to make sure the networking passes to both these networks. Let's say like from here it has access to both these containers. I'm not able to get the file. So it must have access to both the containers. Okay. Mm. So it okay, fine. I don't think it's yes. So you had to make sure the network, like whoever is accessing, like was able to access both the containers. And same way, even if the load increases or the load decreases, like we had to remove this container. And the same way, when we remove this container, we should make sure that it should be able to access only one container. But like what Kubernetes gives as an alternative, before, let's say, you actually were accessing this like Kubernetes pod, and all of a sudden, like if the load increases on your website, that in which like pod is running, you could easily actually add another pod with a single command, and Kubernetes takes care of load balancing and network as well. And you could also set like auto scaling groups, like horizontal auto scaling and everything like based on the load, just like in AWS conditions. We could also set in Kubernetes like horizontal auto scaling as well, like where if the load of the pods increases for 60% or 70%, you could add one extra pod. And like if the load is reduced, you could reduce one unpod. So this way, so like Kubernetes gives a simple orchestration, like even if the load increases, like you could easily add pods with a single command, or you could use horizontal auto scaling group as well, which actually like Docker could not provide. But Docker Swarm, there is this thing called as Docker Swarm, but it was not widely popular because of its like complex architecture, and like where Kubernetes made it easy. So that's why like Kubernetes is widely popular tool. But underlying image, like whatever like inside the pod, the image is run is like by default it pulls the image from Docker Hub itself. So this is mostly Kubernetes is called as orchestrator tool, not a container tool. So here is where like we're calling image like inside port. If you remember in Docker we had opened like in Nginx for like port 80. Same way, whatever port we want to open, like we're actually opening port 80. Since this is a kind deployment, let's say this is actually pod. If I go for like kind pod, you could only have like one pod, like number of manifest files. Deployment is nothing but the same pods itself, but I'm going to tell how many pods that I need. Let's say I need like this is the replicas. This I'm saying I need two pods. However, what this does is like what Kubernetes controller or master node does is like it checks like if I delete a pod accidentally. Let's say like a new joinee came and he deleted a pod accidentally, and like but like since I had mentioned replicas as two, so it checks like the Kubernetes controller plane checks like how many replicas are there like with this image. So it checks like it's there is only one image. So what it does, it automatically turns up another pod. And so this way, even if the accidentally, even if someone deletes this pod, so like it will automatically come up as many times as we do it. But even if someone deletes the two pods, it does the same. It makes sure that it has two pods. So this is about like deployment is nothing but the number of replicas we want in pods. That's it. And here, like once deployment is done, maybe I'll show you practically next. So this is how it does. Like last time I had hosted in AWS EC2, and here is like where I had gone like my React micro K8s is the namespace I created. And this is the deployment. And in deployment, there were two pods, and both the pods were opened at port 80. As I said, like both the ports were opened at port 80. And now what I want to do is like I want to access this pods, and like there is another condition where if I delete this pod, let's say if I delete this pod and if a new pod comes up, the IP changes. So the IP of the pod like changes like every time a pod is deleted and come like and a pod is up. So we could not like ask the user to directly access the pod like because like if someone deletes the pod accidentally, always we had to give him the new IP. So for this to encounter, like we will be using this thing called as service. And service has like default IPs, like this IP does not change at all. So instead of asking user to like access the pod, like we'll ask user to access the service. And from service, like he could access pod even if this pod is deleted, even like the new IP comes. Like the user does not have to worry about, neither does we, because like we're giving IP of this service to the user and this IP remains constant. But yes, let me go. I'll tell you like another problem with service as well. So what I'm going to do is like in service, I had to tell him like what port he has to access. So in service as well, I had given him like something called port 80. In service, I had given this is a service port 80 and I'm telling service to target port as 80. So this would be the container port. So here, if I give this file, the React service is the file. So here, like a service is created, and like for the service, the port is 80. So user would be accessing like service IP colon 80 to access our replication, and like this redirects to pod IP colon 80 every time, and like making our replication up. But like there is another problem with service is that like it could only have internally. Let's say like since I hosted in AWS EC2 unless the user has access to my AWS EC2, he'll not be able to access this application. So what I'll do is like I'm going to enable Ingress. Ingress is nothing but a network like where just like a traffic rules where you allow or like disallow rules. So I'm allowing Ingress here. So this actually creates an something called as Ingress controller. So this ingress controller takes care like which path has to go where. Let's say something like maybe once Google. Let's say like this is actually a website of Google. Like let's say like if I'm accessing a particular ingress controller takes this part and maps Google. Yeah, this is like slash maps. Okay, this is um, this is where like let's say like both of them I had access to like google.com itself, like both domains belong to Google itself. Even it could be like google.com/fonts as well. So like what like ingress controller does is like everything the ingress acts as a domain, and once the domain is there, let's say maybe where is this? Yes, let's say how ingress controller works. Let's say this is google.com, and here I have fonts, here I have maps. And here I have like service pods and the particular things like which where our application runs. Let's suppose example. Maybe let me separate. That's better. So what this ingress controller does is like if I'm as a user, like if I'm accessing like google.com/fonts or fonts.google.com, it actually routes to this ingress, and like from in this ingress, this goes to service and this goes to this pods, and based on that, like for us this web page is visible like fonts.google.com. And now if I search like Google Maps, like what this does is like the domain is the same, it's the same like google.com itself. Now it goes for this maps. Second, yeah, maps. And from maps, it goes to service. And like for service, like pods, since these both are different application, both belongs to google.com. But like since there are like different applications running, like this is how actually like Ingress controller works to navigate Ingress to exactly like which application. So to the exact application it requires. So that's how like Ingress controller works. And here, like once ingress is up, there is like where actually again, let me go for back here. Okay, maybe here. Hmm. So we're actually adding ingress here. And in ingress, what we are telling is like use the service, React service. As you could see, we had used the service like from ingress. Ingress doesn't have any port or something, but by default, like we navigated ingress to React service and React service under port 80. So like this way, what happens is like you'll be able to access application even when the user does not have access to my AWS EC2. Ingress is by default domain. Let's say this is my domain. So haridev.shop. Like whenever any user tries to access haridev.shop, even a public user who doesn't have access to my like system, like which is running inside my local machine, he'll still be able to access. As you could see, he'll still be able to access via Google. Like now this application is not up, so you will not be able to access, but if you click on this. So this is how, but like there is one more thing here, like in Kubernetes that we follow. Uh, this is just SSL certificate. As you could see, like most applications that are deployed in Kubernetes, like they should make sure that they have like SSL certified. Like as you could see, this is not secure. By default, if I access this haridev.shop in Mac, it will not allow me, like if there is like without SSL. So that security is there. And like now, even this is like connection is secure. And to get this SSL, like this is just a different concept from Kubernetes. To drop SSL here, where is this? Yes, you had to create like how SSL works, like everything I'd explained here. Here you had to create an CSR and SSL, and like once that is there, like you had to create a CSR SSL with the private key, and the same private key and the CSR that is generated, like using whatever SSL domain that you use, like they give you a CSR, and that CSR and the private key that you use it to generate the CSR, and both would be actually, we would create something called as TLS certificate inside Kubernetes. Second. Yeah, we are creating TLS certificate. As you could see, I had named Haridev SSL. This is the certificate like which the domain gave, and this is the private key which I generated that certificate. And using that, I'll just like drop this here. As you could see, we're not here. Like this is before SSL certificate, and after SSL certificate, all I did was I added a secret name called Haridev SSL, which is actually our SSL configurations. And like once that is there, like you could have your website here. So to put simply, maybe one second, yes, okay. To put it simply, like this is how your Kubernetes like a Kubernetes application works. Ingress is nothing but your domain. Maybe here my domain is like sagarkakkalasworld.com since I'm running this in Blogger. But if I'm running this Kubernetes, like this is how it looks. If someone tries to access sagarkakkalasworld.com, since this would be in like Kubernetes, it goes for a service like which is actually provided by Kubernetes, and inside I'm opening in port 80, and like this goes for like my pods that's there, and like in pod from this port it will access to, let's say, inside my pod to colon 80. Let's say this IP colon 80 would be redirected to this colon 80, like pod colon 80. Maybe I could also show example with Okay, yeah. Like just an overview is clear, right? Or you guys have any queries because I just went like too fast here? Yes, no? Let me know if you guys have any queries because I'm trying to conclude the session here and like pose this like in next session we'll discuss in detail and with hands-on while we are going for Kubernetes interview questions.